Hello everyone, welcome to the demo theater session ArcGIS Runtime Building Advanced Apps for Android with MVVM. This is Rama Chintapalli, Principal Product Engineer in the Runtime Android team, and I'm joined by my colleague Puneet Prakash. Here is the agenda for today's session. We'll look into Android app architectures. We'll look into Android app structures and the evolution of the architectures in general over a period of time. Then we'll look into some of the MVVM principles in practice. And then we'll also look into Android Jetpack components that are required to implement MVVM principles in your application. And then finally, we will use one of the ArcGIS Runtime Android applications, which is an open source app, to demonstrate some of the MVVM principles and the patterns. So let's look into Android app architectures. Before talking about the architectures, let's get an overview of how the Android app structure would look like. Uh, Any Android application typically will have these layers of development where you have an UI layer to present it to the user and take feedback for the user interactions. And then you'll have a data layer which makes all the network requests or the database connections and streams the data to the UI layer. And then you will have the business layer which kind of controls the data and the UI. This is very generic to any software application, need not necessarily be mobile or web. Uh, you will have these layers or components in your app. So then the question arises, why do we need to follow an app architecture to build applications? Why can't we just build with the flow, which includes the code to work with any of these layers uh, without really following any pattern? The answer to it is architectures bring that consistency to the world of software development. They kind of serve as an high-level guidelines or rules for designing your applications, and the architectures really make developers right, and it's a proven and consistent way to easily understand the code, easily make it more scalable, and also make it less prone to errors. So there are some really good advantages to following these practices and architectures. So let's look into one of the early Android app architecture, which is the model view controller architecture. Here, the model is the data layer, which is responsible for managing the network requests and accessing databases. The view is the UI layer, and the controller is the one that handles the business logic and which notifies the user behavior and updates the model as needed. And MVC has been there for a long time, or it is the beginning architecture with which with most Android applications were built with. Uh, in Android in specific, the activities, fragments, and views would constitute the views in the MVC model, and the controllers kind of are separate classes which don't extend any Android classes in general, and the same applies for models as well. So the view here in MVC depends on the controller as well as the model, and the dependency of the view on the model starts to bring some downsides, especially when the views are a lot more complicated. And if you remember the early Android architecture code, like the activity itself is kind of a combination of view and a controller. You would have to embed both the code in the same activity, which kind of makes your activity code just grow in size as the app grows. And there is no clear separation between the views and to be treated them purely as view components. So so it needed some refining to this architecture, and that's when people started adopting to a new pattern, which is the model view presenter uh, architecture. So in MVP architecture, again the clear distinction is there is a separation of the view from the presenter, which was not there in MVC. And in MVP also you have the same UI layer as the view, and then there is a business logic that controls the UI and that the model, which is where all the logic is now moved to the presenter. Presenter is the one that now interacts with model and updates views. So it did create that separation between the view and the which is the UI layer and the logic to control the model. So that separation has happened, which kind of reduced the amount of the activity code, and then people started putting moving code to the presenter itself, and the presenter kind of now is now holding or now handling the all the logic for the app. And one of the downsides with MVP is, as again as the app size grows, like the views in MVP needs to hold reference to the presenter and vice versa, and the communication was happening between the models and presenters via callbacks. So so over a period of time, although we were able to separate it, the logic kind of uh, bloated within the presenter classes. So the presenter now has become the all-knowing class with a lot of code included in it. So then people thought about coming with a newer architecture, which is what is MVVM. And in MVVM, it almost appears similar to MVP because both of them has a clear distinction of the view and the presentation, which is the business logic, which is now is termed as model view, uh, and the model is still separate. MVVM pattern was created to simplify that interaction between the view and presenter in the MVP. So now, like with view and model view, it is that interaction between the callbacks is simplified with an event-driven programming, where a two-way binding data binding between the model view and the view is created. So in MVVM, the view has a reference to the view model, but the view model doesn't have any information about the view anymore, and all the communication is only managed through events. Uh, so so that's where we are currently with the MVVM patterns. Again, as I said before, these architectures by no means kind of very kind of hard and set rules that we have to follow, but these are something nice to build your applications, especially you want to grow your application and take it to a larger scale, and these architectures would really help you in accomplishing those complex app logics. And as I said before, MVVM is probably not the last architecture to be worked on. There are few new architectures being discussed in the Android world. There is a new pattern called Model View Intent architecture, which is still in works. But as of now, MVVM has been the go-to application architecture for people. So that's where our focus of this session is, and with that introduction, I would like to hand it over to my colleague Puneet, who is gonna take you through the MVVM principles uh, in practice, and give a deeper understanding of how it works, and he'll also show us some of the code uh, that he has been working on with one of the open source apps.
Thanks, Rama. Let's take a deeper dive into why there is a need for MVVM in Android and how it is implemented. Let's just think about the constraints we have to consider when we are designing our mobile app. Well, for a desktop application, we have a single entry point from a desktop or a program launcher. Then, it runs as a single monolithic process. Mobile apps are different than desktop apps and have much more complex structure. A typical Android app contains multiple app components such as activities, fragments, services, content providers, and broadcast receivers. We declare these app components in the app manifest. The Android OS then uses this file to decide how to integrate your app into overall device's user experience. User often interacts with multiple apps in a short period of time, and the apps need to adapt to different kind of user-driven workflows. Consider a workflow when a user wants to update a feature by adding a picture to it in a web map via the Collector app. The Collector app triggers a camera intent. The Android OS then launches the camera app to handle the request. At this point, the user has left the Collector app, but their experience is still seamless. The camera app might trigger other intents like launching the file chooser, which may launch yet another app. Eventually, the user returns to the Collector app and shares the photo. At any point during the process, the user could be interrupted by a phone call or notification. After acting upon this interruption, the user expects to be able to return to and resume this photo sharing process. This app hopping behavior is common on mobile devices, so your app must handle these flows correctly. Keep in mind that mobile devices are also resource constrained. So at any time, the operating system might kill some app processes to make room for new ones. Given the condition of this environment, it is possible for your app components to be launched individually and out of order, and the operating system or user can destroy them at any time. Because these events aren't under your control, you shouldn't store any app data or state in your app components. And your app components should not depend on each other. It's possible for your app components to be launched individually and out of order, and the operating system or the user can destroy them at any time. This leads us to the common architecture principles that we should stick to when we are designing the architecture of our app. The first one being separation of concerns. It's a common mistake to write all your code in an activity or a fragment. These UI-based classes should only contain logic that handles UI and operating system interactions. By keeping these classes as lean as possible, you can avoid many lifecycle related problems. We don't own implementations of activity and fragment. Rather, these are just glue classes that represent the contract between the Android OS and your app. The OS can destroy them at any time, based on user interactions or because the system conditions like low memory. To provide a satisfactory user experience and a more manageable app maintenance experience, it is best to minimize your dependency on them. View models are persistent components that are responsible for handling the data for an app. They are independent from the view objects and app components in your app. So they are unaffected by app's lifecycle and associated concerns. Persistence is ideal for the following reason. Your users don't lose data if Android OS destroys your app to free up resources. Your app continues to work in cases where network connection is flaky or not available. By basing your app on model classes with the well-defined responsibility of managing the data, your app is more testable and consistent. So we should always be driving a UI from the model. So view model pattern, architectural pattern ties in the positives of separation of concerns and driving the UI from the model. We also follow what is known as a single activity model, where the entire app we just have one activity and all the transitions between UIs happen using fragments. Let's look at this diagram, which shows how all the modules should interact with one another after designing the app with MVVM. In MVVM, view model exposes streams of events to which the views can bind to. This is done in Android via live data. Live data is an observable data holder class. Unlike regular observables, live data is lifecycle aware, meaning it respects the life cycle of other components such as activities, fragments, or services. The repository is the only class that depends on multiple other classes. In this example, the repository depends on a persistent data model and a remote backend source. This design creates a consistent and pleasant user experience. Regardless of whether the user comes back to the app several minutes after they have last closed it or several days later, they instantly see a user information that the app persists locally. If this data is stale, the app's repository module starts updating the data in the background. Now let's look at the Android Jetpack components that help us build a modern Android application based on MVVM. First and foremost, data binding library. So the data binding library is the support library that allows you to bind a UI components in your layouts to the data sources in your app using a declarative format rather than programmatically, which means now you don't have to tie the data inside your fragments, but you can just do it in your layout XML files. Binding components in the layout files let you remove many UI framework calls in your activities, making them simpler and easier to maintain. This can also improve your app's performance and help prevent memory leaks and null pointer exceptions. Lifecycle aware components perform actions in response to change in lifecycle status of another component, such as activities and fragments. A common pattern is to implement the actions of the dependent components in lifecycle methods of activities and fragments. However, this pattern leads to poor organization of code and proliferation of errors. By using lifecycle-aware components, you can move the code of dependent components out of the lifecycle methods and into the components themselves. Live data is an observable data holder. Other components in your app can monitor changes to the objects using the holder without creating explicit and rigid dependency paths between them. The live data component also respects the lifecycle state of your app components, such as activities, fragments, and services, and includes cleanup logic to prevent object leaking and excessive memory consumption. A view model object provides the data for specific UI component, such as a fragment or an activity, and contains data handling business logic to communicate with the model. For example, the view model can call other components to load the data, and it can forward user requests to modify the data. The view model does not know about the UI components, so it isn't affected by configuration changes, such as recreating an activity when rotating the device. There are other Jetpack components too, such as paging, room, work manager, but we're not going to go into details of that because they directly don't apply to the app that we are going to discuss next. Which takes us to our next slide to uh, present to you the data collection app, which is an open source example app demonstrates how to use ArcGIS platform to collect features and related records, both online and offline, using the ArcGIS Runtime SDK for Android. It helps you collect your own organization's data in an app driven by ArcGIS WebGIS information model and configured through your organization's web maps. It is done using the latest cutting edge tech available to us. It's written in Kotlin. It uses Jetpack architectural components. At the beta 0.1 release, we currently have authentication via OAuth implemented. It works with an ArcGIS Online web map configuration driven architecture. It can perform identify and view results via map view, and it can enable you to view existing data via pop-up and attributes. Now, let's just look at the demonstration of the data collection app and then dive into the code where we can look into the architecture of the app as well. Let's take a deeper dive into the data collection app. So here we have the data collection app launched up and ready to go. The app displays the Portland Tree Survey map, which is a web map displaying all the trees that are available or planted in the Portland metro area. The user can pan around the map to see all these trees, and they can click on a particular tree to get more information about the tree. Once the user taps on the map, an identify operation is performed and the results are returned. We pick up the top results from the list and display it in the bottom sheet down here, where we get the neighborhood in which the tree is planted and the title of the tree. Over here it just says trees. The user can then tap on the bottom sheet to expand it to get more details about the said tree. At this point, the user can decide to click on the edit button and edit the editable fields that are available for this feature. After making the edits, the user can decide to click OK to save these edits or to cancel the edits. For the purpose of this demo, we're just gonna cancel the edits at this time. And here we are given a pop-up again in a dialog to confirm a discarding of a changes. You're going to press OK on it and move forward. Now let's look at the code that goes behind the working of the app. Let's just first look at the architecture. The app itself is a single activity app with data collection activity being the sole activity that comes into play. We can look at the navigation graph for the main activity, which says in the main navigation, what we do is we launch the data collection fragment. That is the main fragment that you see once the app is launched, which contains the map view in it. Now let's look at each fragments that are responsible for all the views that we just saw in the demo. The data collection fragment being the first and the centered fragment that we see once we launch the application. Data collection fragment has a data collection view model associated with it, which manipulates all the data and drives the UI for the data collection fragment. All these fragments also have many-to-one relationship to the view models. Here we see the data collection fragment contains a data collection view model, which also connects the map view model. It also connects the pop-up view model and the identify result view model. The map view model contains properties such as the map that is being displayed in the app and a property called identifiable layers. Identify layer property defines the feature layer data collection wants to perform identify operation on. This map is declared is linked to the map property that is in the map view. Here we see the map view inside the layout, and by data binding we are able to do it declaratively inside the layout file itself, where we specify the map property for this map view being equal to the data collection view model, which contains the map view model and the map property for it. This map property gets initialized in the map view in the data collection view model once the portal has been loaded, and we update the map. The other methods that are present in the data collection view model are values such as the portal URL that is being used in the web map, the item ID that is being displayed, and the properties required for caching the credentials and also for making the OAuth authentication possible. When the data collection view model is created, we initialize the credential cache, we encrypt the credentials, and we look for the credentials if they are present, then reusing them so the user won't have to relog in. And we do operations such as sign in to the portal and sign out of the portal. Next up is the identify result fragment. This comes into play when the user performs an identify operation on the map view and there is a set of results that are returned. The associated result view model is the identify result view model, which holds on to the value that of the identify layer results once the identify operation is performed. It also has live data properties for events that are fired and that help us navigate between the data collection fragment and the pop-up view fragment. Now let's look at the pop-up fragment. The pop-up fragment is what we see once the user taps on the bottom sheet and expands it and lets us view the pop-up view. So the pop-up fragment, and we can go into greater details into it to see how the Jetpack components help us implement MVVM. So once the fragment is created, we initialize and declare the pop-up view model. And then in the onCreate view, we go ahead and we inflate the layout by using data binding util inflate method. This returns to us the binding that is associated with this layout. Then we bind the variables defined in the layout with the pop-up view model that we just declared and initialized in the pop-up fragment. We associate the lifecycle owner of the binding to the fragment's lifecycle. So the bindings will get destroyed once the fragment is destroyed. Here, in the layout file itself, we declare some variables so we can use binding expressions inside the layout so we can bind method calls in our view model to the properties or the on-click listeners defined for the views. After defining the bindings, let's look at how things were being done before and how they have improved with MVVM. So earlier, if there was a button and we wanted to perform an operation once the button was clicked, we'll set an on-click listener on it. This expression is sort of equal to doing a find view by ID and then finding the edit button and then setting an on-click listener on it. It can be simplified by saying binding.edit set onClick listener. And then here we can have the code that we want to perform once the user presses on the button, which in this case would be to set the edit mode on the pop-up view model, uh, which triggers an event and sets the properties on the pop-up manager. But with data binding, we can omit this and reduce our code that is being used in the fragment by doing it directly, declaratively in the layout file itself. So we can remove this here, and let's see how we have used it in the layout file itself. So we have an image view of the type, and the ID of it is the edit button, and we can declare the onClick listener and have a binding expression for it, which is a lambda expression here, where we specify that when onClick is clicked, we want to call pop-up view model set edit mode method and pass a value true to it. Similarly, we also associate the property of visibility with this binding expression, where we specify to check for the value of is pop-up in edit mode live data value. And we have a ternary operator here. So if it is true, then the view will be gone. And if it is false, then the view will be visible. And that is why we needed to import the view variable up top so we can use it in the binding expression down there. Moving forward, let's see if we have a button like an OK button and we want to set an onClick listener on it, and having our code in the fragment, we would have to have all this code which is required to set those edits back onto the web service, which implies all these operations to be performed using the pop-up manager and setting those apply edits and checking for exceptions if they were thrown while you were trying to apply that edit and propagating back to the user. It would have been easier to propagate those errors if we had this code in the fragment here itself, but that will mean a bloated fragment class. What we can do is with MVVM, we don't have to have this code over here. We can just get rid of it and move that code into a function call in our view model, such as this, where we can just call, if the user presses on the OK button, call the pop-up view model save pop-up edits method. So here we see the entire code being here. We can even simplify this by not even having this call here and doing it directly in a layout file itself. And in the layout file itself, when the user presses OK, we specify that the onClick method with this lambda expression to call pop-up view model save pop-up edit method. So this is all about the UI calling the methods in the view model. But how about the view model driving the UI when the changes in data happens? So for that, we utilize events that are mutable live data objects in the pop-up view model. So, and in the fragment, we are observing those events. So in the pop-up view model, we have events for such things to happen, where we have an event where we look for if the pop-up is in edit mode or not, and then we raise events for showing the save pop-up error event or showing saving progress event and confirming when the pop-up edit event is done. In the pop-up fragment, we have these observers that observe all these mutable live data properties. So once those values change to true, we will display a progress bar, and we set the visibility of the progress bar to visible if it's true or false if it's not. We also are observing events such as show save pop-up error event. So we will get notified by the view model as to when we want to show those pop-up error event. Once those values are changed or set, we'll show an alert dialog with the error message that is being sent to us by the view model here. And here, this is simple. We just monitor this event where we just want to display a dialog for the user to confirm if they want to cancel the pop-up editing event or not. Once that event is fired, we will display a dialog which will prompt user to confirm the cancellation of editing event. That's all I have to show you regarding the data collection app. Back to you, Rama.
Thank you, Puneet, for that presentation and showing us some code today. Uh, with that, I just want to quickly recap what we did today in the session. We talked about the Android app architectures, the evolution of the architectures, different architectures that Android world has been using. And then we talked about MVVM principles in practice. We looked into the Android Jetpack components that are required to make MVVM work in your application. And then we also looked into the ArcGIS Runtime Android app, the data collection app, uh, and looked into the code of it and see how the MVVM has been used in the development of that app. So with that, so I would like to conclude the session and request you all to provide your feedback for this session by clicking on the link that is provided directly below the video. And thank you very much for attending the session.